Okay, our second speaker this afternoon is Christopher J. Biggs, who comes to us from Accelerando Consulting in Brisbane. Christopher is also the convener of the Brisbane Internet of Things Interest Group and a founding member of the Brisbane Open Users System Group, Humbug. You may also remember him from a presentation on Monday entitled The Awful Design of Everyday Things. I certainly do. Today's presentation is called Privacy-Preserving IoT. Please give our speaker a warm welcome.
Thank you for coming along. And when I say thank you everyone for coming along, I mean the 161 mobile devices that I've enumerated and logged in this room. Your attendance will go down on your permanent record. And if you're ever involved in a privacy breach, your insurer will refuse your claim because they know you were here and should have known better. So pay attention. I come from Brisbane, which is a little village just up the road. In that village, I am the descendant of the village blacksmith. My ancestors took their plough to the blacksmith to be mended. Your parents probably took their car to my father to have the brakes fixed. And today people bring their robot vacuum cleaners to me to find out if they're secretly recording upskirt videos. At Accelerando, we help people enlist computers and robots to make their lives easier without that inconvenient moment where they rise up and exterminate us. And before I go on, some more shameless self-promotion. Another of my hats, as mentioned, is the Brisbane Internet of Things Interest Group. And this group offers a learning environment to help you and all of us to steer towards a livable future. So if this presentation sparks your interest, you're encouraged to join us. And we also do practical workshops where we get hands-on with this stuff, and you can find more information about that on Meetup. So I mentioned creating a livable future. And one of the things that I want to do this afternoon is to give you some perspective on why I think the Internet of Things can be a positive force multiplier. On Monday, I said the Internet of Things was itself a silly name because it faces the wrong way. Sure, these devices talk to the internet, but what's important is the things that they do for humans. They are human-centered technology. So I'll keep using the term Internet of Things today, but I want you to remember that they work for us. We are their purpose, and evil is what happens when you start to treat people as things. Whatever you want to call it, I have my own definition of the concept we call IoT, and it is this. The Internet of Things is the fusion of inexpensive embedded devices, pervasive wireless communication, and cloud computation aimed at enhancing human perception and agency. IoT promises a future where we can extend our vision and reach as far as we want to go, where each human thrives at the center of their own extracortical web of sensors and agents. And if we treat human-centeredness as an axiom, then this leads to what I call my 3 laws of IoT. Devices must cooperate for the benefit of humans. Devices must communicate and obey instructions. Devices must be as simple and reliable as possible. And if you squint a little bit, they look like Isaac Asimov's famous 3 laws of robotics, which he imagined as a minimum constitution that we would need to embed into our technology to prevent it, to put it bluntly, from killing us. And these IoT laws serve something of the same purpose, which is to prepare the stage for a future where our technology has inherent checks and balances that serve to protect our agency and safety. But Asimov got to retrospectively sneak in a 0th law, so I can do that too. Devices must be beautiful or invisible. If we invite computers into our living rooms, bedrooms, bathrooms, and even our bodies, they can't look like truck parts, and they definitely need to be working for our benefit, not for somebody else's profit. Last year, Linux.conf Australia featured a keynote from Diane Hosfeld, who talked about the struggle to retain control of the insulin pump that keeps her alive. The year before that, Karen Sandler told us of her unease at the concept of an implanted defibrillator that has wireless communications. For many of us, this is not a theoretical conundrum. Out of sight cannot be out of mind. Somebody needs to think about justice and privacy and safety and all those big things that we believe in to make society different from a herd. And as Lana Brindley said on Tuesday morning, until and unless we make ethics and safety a software project role in its own right, the somebody is us. Which brings us crashing back to the unglamorous present. We have, as has become ever more distressingly apparent, collectively built an internet that feeds on attention. It sells it, along with our behaviour and habits, to whoever will pay. And it's big business. As the saying goes, if you're not paying for the service, you're not the customer, you're the product. 2 of the 4 biggest technology companies in the world are now essentially the hollowed out corpses of their former selves, animated and controlled by the parasitic wasp of advertising. And I'm not really sure that the other 2 aren't. I don't really know how we get out of the trap that we've wandered into here, where both our mass media and our interpersonal communications are tools that have become honeypots that feed on our privacy. But I have baked you a cake today that contains a file and a few other tools that might let us tunnel out of here. So bear with me for a moment, because before we cut the cake, I want to frighten you some more. Do you notice how there's a whole step at the supermarket checkout, whether human or robot mediated, that badges you for your loyalty card? They time the toilet breaks of their staff. They aren't spending 10 seconds of every checkout pestering you about this because they want you to have that flight to Bali. What are they doing? Loyalty programs are about collecting your behavioural data to build a digital double of you that can be imprisoned and tortured until it gives up the secret of how to make you buy more stuff. And you might think, well, I just won't show them my loyalty card, but they've already linked your bank account to a shadow profile, and whether or not you choose to give up this information, they probably have it anyway. It's all about the Nellies. I nearly said the Dougies, but that was the old ones. For the confused, I'm talking about Australia's $100 bill, which you almost never see in the wild these days. Cash is so inconvenient to track, and tracking is everywhere. Around this time last year, I read an interview with the CTO of a smart TV company who admitted that if you wanted to buy a dumb TV that did not include their applications or tracking software, then they were going to have to charge you more to make up for the income that they lose from selling your behaviour. This isn't human-centred technology, this is us as the fly in somebody else's web. We've come a long way down the path at being at the mercy of technology, and some of the technology out there is quite frighteningly merciless. And there are signs that things are getting worse, not better, but I think we have the tools at our hands to reverse this trend, to dig our way out of the pit. The Chinese government have created a system where your entitlement to government services and even the right to travel is determined by your behaviour as observed by a pervasive grid of internet and physical surveillance. Here in Australia, the expanding use of data matching by our own government leaves little doubt that their ambitions lie in the same direction. I worry that we won't be able to rely on our bureaucracy's hilarious and total inability to computer as a measure of protection forever. We've had robo-debt, which yanks the social security net out from under the disadvantaged. We've seen in the last year how travel records and IMSI catchers can be used to establish who was at political demonstrations in Hong Kong, in the USA, coming soon to a city near you. And then there's the private sector. If supermarkets think they know everything about your behaviour, you can bet they're selling this data on to your insurers. And if you buy all your fruit and veg at the farmer's market for cash and only buy your junk food at Woolies, what is your health insurer going to infer about your medical risks? If you were to develop diabetes later in life, would your insurance company pull up the records from your supermarket loyalty card, estimate your lifetime junk food intake, and use this to deny your coverage? If you have an automobile crash, do you really want your insurance company second-guessing whether or not you ought to have avoided it based on their post-facto reading of your sensor data? Here's a story from the Middle East early last year. This is the outline of a military base in Iraq, showing the fence lines and patrol routes and convoy corridors, assembled from the aggregate Fitbit data of US troops stationed in Baghdad. Since almost no locals in some of these countries that have been bombed to a dusty crater by the United States have Fitbits, it's easy to infer that the ones that you see belong to US soldiers and contractors. What's worse is that the US military gave out thousands of these devices to their chunky troops without realising that they were giving away more than they intended. And there's one particularly concerning story that emerged last August and just kept getting worse. There was a series of reports and rumours and then denials, but eventually it was confirmed by investigations by the US Senate that hundreds of police departments in the United States have an agreement that gives them warrantless access to recordings from a certain large corporation's video doorbells, but only in 12-hour chunks, and only if there's been a crime, anytime in the last 45 days, anywhere within half a mile, and that hardly ever happens, right? With stories like this, you could be considering throwing away all your IoT devices into a barrel and burning the lot. But I don't think many of us really want to put the genie back in the bottle. Do you remember the Yellow Pages? Have you used it lately? Besides holding up your monitor? Sometimes you get these moments where it becomes undeniable that we're living in the future. We're now beyond the years where science fiction classics like Blade Runner, Back to the Future, Snow Crash, and Akira were set. And our world today looks a lot more like those futures than it resembles the Dark Ages up there. I was passed by someone on an electric longboard this morning, and it was close enough for my taste to a floating skateboard. This is a Radio Shack advertisement from 1985, and almost every single piece of technology in that advert is extinct now, and what's more, everything up there is now a function of your phone. If you showed your phone to yourself or your ancestor from 1985, I think they would put it on a level with a floating skateboard also. So, I'm done now talking about how horrible everything is, and now we're going to look at what, as a person, you can do to protect your informational integrity, and what we can do as creators to build systems that protect people's privacy rather than strip mining it for cash. So let's take a deep breath, absorb some Quokka energy, and take inspiration from Donna's keynote on owning our power to leave the world better than we found it. A long time ago, in a valley far, far away, a bunch of nerds took the idea of the World Wide Web and built a commercial enterprise boom on it. And then that blew up. But after a while, they built a second one. The second dot-com boom was the social media revolution. Some heroes of the first boom turned out to be evil, and some new heroes arrived. Not a few of those turned out to be villains too. .com 2.0 promised to sort out our email and keep us in touch with our school friends and let everyone know what you had for breakfast and what funny thing your pet just did. What we got mostly was targeted advertising and space Nazis. Later, those same companies took the pots of cash that they made from monetizing our eyeballs and branched out to hardware. Or much of the time, they gobbled up a number of smaller companies, the ones that didn't run fast enough. Siri, Alexa, Nest, Ring, these all started off as plucky little independent players who were going to bring power to the masses. And what happened was they were assimilated by the galactic empires. And so the Internet of Things, at least in its consumer manifestation, was strangled at birth by the advertising industry, replaced by hollowed out corporate changelings. And as Kathy Reed highlighted yesterday, data about our private lives and bodies is frequently being gathered and stored and warehoused and treated as a corporate asset, no longer our property. Here I go. Preaching fear and paranoia again. I promised I was done. I really am done this time. Have another Quokka. Okay, so how do we maintain our digital integrity in this environment? What sort of approaches might we take to turn this around? Can we wrest control back from the Five Eyes of Silicon Valley, or do we just burn it down and start afresh? To be honest, I'm leaning more towards the latter, and I'm going to tell you about some of the things that we might do if we were starting over. Obviously, one thing you could do to safeguard your online privacy is to check out of the whole rodeo. Abandon the benefits of the internet along with the problems. Move to a cabin so far back in the woods that you need to bring daylight in by pack mule. But that feels like defeat. And while Dr. Brady's keynote from Tuesday reminds us that there is a time to drop your phone in the toilet and go to that protest carrying nothing more technical than a zippered hoodie, I'm not ready to give up fighting for digital ethics. But you can't lose control of data that you don't share. So the second thing we can consider is what data we share or collect. If your doorbell camera happens to also look over your neighbour's swimming pool, then you can mask out that area of the frame in camera. There are totally cameras out there that already let you do this. Our investigations at Accelerando show that it is unlikely that everything you say in front of your home telescreen, I mean voice assistant, is being transmitted to the thought police, but you will observe that the wake word detection is deliberately fuzzy. Any collection of syllables that has a similar enough shape to the configured wake word, be it OK Google or Hey Siri or Alexa or something that sounded a bit like Alexa, might cause your voice assistant to start listening and transmitting and recording. So a special case of not uploading data is to process more data in the field and send less data to the cloud. And there's a phase shift happening in IoT at the moment. Use of AI and computer vision was something that had to happen at the back end, in the field. Sorry, at the back end. But this is changing. Lightweight machine learning tools that can run in the field are here. And the processing power of sensor devices is getting considerably better quite rapidly. The open source FPGA folks are doing amazing work in making the deep voodoo of field programmable gate arrays more accessible. These technologies open up exciting possibilities to lessen our reliance on cloud services. If you see Tim Ansell or Sean Cross around the conference, ask them about their product called FOMU. If you don't, I guarantee you will get FOMO, and you have no idea how hard that is to say. If you're choosing or building IoT solutions, consider how the data gets from the device to the cloud. I've seen video distribution systems that can be viewed and even reconsidered by anyone who's on the network. I've encountered one business who is using IoT gateways that connect their high voltage equipment to the internet with exactly 0 securities. I do want to give a positive shout out here to Amazon and Apple, because what they're doing is they are essentially outlawing the use of unencrypted connections in their ecosystems. If you have an Apple app and it uses plain HTTP, you have to have a very good reason why, or they won't even let it into their app store. And Amazon does the same thing with their IoT ecosystem. It's 2020, people. Encrypt your connections. Our processes are fast enough. The certificates are easy enough to get. This shouldn't be a problem anymore. If you won't do it because I will come and shout at you, do it because a number of countries are enacting product safety laws which are going to force you to do this. Come to think of it, why does Amazon or Google even need to have a record of everything I've ever searched for, or everything I've spoken in the presence of my voice assistant? Maybe they've got a reason, but I really doubt it's good enough. As a business, every piece of personal data you store is a liability. Sooner or later, there's going to be a leak. And as an individual, every piece of your personal data that you let someone else store is something you might see on a front page someday. The cyber insurance industry has a role to play here, I think, much like how the payment card industry has worked to eradicate lazy practices. If you become the victim of credit card fraud and the payment card industry audit reveals that your practices weren't good enough, not only will your insurance not pay, there are considerable penalties. And I expect to see the same kind of thing for privacy. And most of these biggest privacy leaks of all time have been due to poorly secured databases or open by default file stores. It really ought to take more than one mistake to lose control of private data. Don't leave files around where anyone can see them. Don't put your SQL database on the same machine as your web server. Just pretend for a second that privacy is as important to your business as money and get serious about it. I even wonder why some cloud services need the key to our data at all. What exactly does Amazon do that requires them to look at my doorbell camera footage? It's on their servers so that I can access it, but they don't need to see it. So why isn't it encrypted with only me having the key? The approach of not even holding the key for a data vault works for password apps. Why not for everything else? Fitbit stores the history of your exercise so that you can gloatily share them with your friends, or whatever it is that people who run do with that data. But Fitbit themselves shouldn't need the details. Your browser or phone is drawing a vector route over a bunch of map tiles that are probably both coming from different API services. So Fitbit doesn't really need to see either of those things. And I can even envisage a replacement of Facebook where the entire content of posts is opaque to the service. If I'm posting a 30-second cat video for my 300 friends, the space for 300 individual encryption keys for my friends to be able to read the post is a rounding error in the amount of data. Calm down, I'm not seriously suggesting that you ask your in-laws to PGP encrypt their Facebook updates. I'll let Fraser suggest that. But PGP is an encryption program that was invented in 1991. It was so revolutionary at the time that the US government spent several years attempting to charge the author as an arms trafficker for letting his software leave the country. But thanks to its famously unfriendly user experience, it didn't exactly take off. In almost 30 years of maintaining a PGP key, I've been asked for it in a business context exactly once, and I nearly fell over when that happened. But this program does exactly the kind of thing with your private messages that most cloud services ought to be doing today. Now, in the keynote this morning, we had some maths, but I'm going to do something even more difficult. I'm going to try and explain public key encryption without any maths. This is also called asymmetrical encryption. Instead of having one password, you have two. One is what we call the public key. It's your nerd phone number. It can encrypt a message such that only the private key, which you keep on a string around your neck or inside your cybernetic implant, can decrypt. If I want to post a picture of the truly righteous eggs Benedict that I ate this morning for breakfast, then I generate a random password, I encrypt my photograph. And then I take the public keys of the nerd phone numbers of each of my 300 odd friends, and I encrypt that random password with each person's key once in repetition. And then I bundle that up, and that goes up onto the social media. And each person who's allowed to see my selfie can use their private key to decrypt their copy of the unique password. And that might sound complicated, that might sound like a lot of work, but that's essentially what our web browsers do every time they make a secure connection today. So, next level of aggressiveness, why do we even give our data to cloud services? We put our money in the banks for potentially good reasons, because they're insured. If they get robbed, we get our money back. But if a cloud service sells our data, or forgets to secure it, or is hacked in a data breach, we don't get our privacy back. So let's consider some alternatives to centralized data storage. There's a story that Robert Heinlein used as a metaphor in one of his novels. There's this old man who's employed to polish the brass cannon out front of the county courthouse. One day somebody asked him about his retirement plans, and he said, I've saved a little money. I'm going to buy a cannon and go into business for myself. Running your own cloud data storage might sound a bit like that. Is it really any different to having someone else store your data? Well, if others have only got at-need access to your data, it's harder for them to resell it, to lose it, to stockpile it. And of course, if you encrypt it at rest, with multi-party encryption, as we've already covered, if you've agreed to share something with Alice and Bob, but not Carol, then even if Carol steals your service or hacks your server, there's no loss. It doesn't even necessarily have to be in the cloud. Maybe what you want is a home safe full of memory chips with an antenna sticking out the side. Right now, loading a web page involves taking hundreds of HTTP connections to dozens of servers in order to load up all the tracking cookies and ads and JavaScripts that we adorn our websites with. So I don't think collating data from the individual vaults of dozens of owners in order to assemble some result is really a different scale of problem. If it's sauce for the goose, it's sauce for the gander. Look, your phone could even be your personal data vault. I did a back-of-the-envelope calculation, and the total size of my entire Twitter output going back a decade is about the size of one song. So there's room for it in my phone. But what if the cat's already out of the bag? You gave your personal data to a bunch of scumbags and you're not happy with what they did with it. Well, if you're European, you have GDPR, the EU General Data Protection Regulation on your side. You can demand that a company supply what information they have on you, and if you don't like what they've got, then you can demand that they delete it. There's similar legislation in the pipeline elsewhere, notably not in Australia, I'm afraid. California's equivalent went live this month. In some ways it's more powerful, and in some ways it's less powerful. One of the lesser powers is that it doesn't extend to resold data, nor does it give you the right to demand erasure of data that is in the public interest. So that little arrest record from the time that you tried to borrow a quokka from the zoo for a weekend, I'm afraid is going to stay up. Now, I'm not making all this stuff up about personal data vaults. This stuff already exists. In the middle of last decade, a UK consortium of 6 universities researched what they called multi-sided market platforms. And they built an implementation called the Hub of All Things, HAT for short. This effort was spun off into a commercial enterprise, now known as dataswift.io. Now, I don't have a connection with any of these organisations, I just like their ambition. Last year, they sponsored the creation of the Ethical Tech Alliance, which is a network of companies and developers that promote, well, ethical tech. But what does ethical tech mean? Well, it means technology that takes, as Lana urged on Tuesday and Marissa spoke about just now, responsibility for the consequences intended or otherwise of its use. Technology that recognises users' privacy rights as enshrined in law. Technology that represents the needs and desires of users, not just corporations. Technology that preserves privacy by design. Technology that ethically handles identity and is inclusive and empowering. And technology that champions environmental sustainability, not, for example, technology that bricks itself on purpose when you try to recycle it, looking at you, Sonos. Here's how it works. A HAT is your personal data vault. You get to decide what services have access to what data. You choose someone you host to trust your HAT, or you can host it on your personal device. You can then choose to then install plugs, which are software modules that connect to other services and bring data into your HAT. And in the other direction, you grant apps access to data within a certain namespace. If you're up to date with the way that applications on iOS and Android will pester you for permissions when they need to do certain things, then this is in the same arena. Apps will ask for permissions when they need it, and you have the choice to grant or not, and the option to revoke later. And the final piece of this HAT ecosystem are what's called tools, packaged applications or even machine learning models that reside in your HAT, pull in some data, do some computation, and deposit the result into your own personal data store. The important thing here is that the computation happens in your trusted environment, not somebody else's. But the challenge with an ecosystem like this is bootstrapping. It won't get popular if nobody implements plugs, and nobody will do that for a service that isn't very popular. So those folks at DataSwift are addressing this via their Ethical Tech Alliance. The platform provides a way for startups to bootstrap their data ecosystem with less effort, not more. They've also implemented plugs for some of the big services like Facebook and Twitter, which can pull your posts and tweets into your HAT where you can share them with other apps. It's still not clear, however, how anyone would convince a big service like Facebook or Twitter to do the other thing, which is where all your posts and tweets live in your phone, and they only get access to them when they need them. But let's go deeper now into the potential of inverting the power relationship via trusted computing. Currently, data sharing is a leap of faith. If I share my data with some service, I lose control over what happens next, whether that data gets used for what I expected, or whether that data gets kept secure, or whether it gets flogged off to a crime syndicate. So we're going to move away from social media now and look at what can happen in the Internet of Things with sensor data, be that agricultural or biological or commercial. You've collected some data, which you use for your own purposes, but it could have the potential to be valuable to others if you could share it ethically. And there are other entities that want to do things with your data. Maybe insurance companies want to measure your fire risk or your accident risk. Perhaps a drug company wants to measure the efficacy of their drug from your biomonitor data. Naturally, you're a little bit creeped out by handing over intimate details of your bodily operations, your business operations, or your behaviour. So can we get past that? Is there a way to satisfy everyone? Well, not unlike what Opal spoke about in her presentation on data collection, the question matters. An insurance company might simply want to know your percentile rank for certain driving characteristics. It might be a case of, if you're in the top 20% of safe drivers, you get a 10% discount. A drug company might simply want to know if there's a correlation between time of day and some symptom. The point is, there's often a simple aggregate value that is all that's desired. Once the code is written and the calculation is done, nobody actually needs to look at the raw data. So let's turn that problem around. Rather than one party supplying the data to the party who wants to run the code comes to the data. Or if there are multiple data suppliers, then it all goes to a trusted third party who runs the algorithm and sends the answer, which of course can't be print out all the input data, back to the original person with the question. It is kind of like Java applets all over again. Now, this is an example where I do have an interest. There's a startup called the SAM project that have been operating an ecosystem like this since 2013, and they've been my client for just under a year. Late last year, we built a new iteration of their platform that I'm about to describe, and right now we're building a mobile app to put this platform into the hands of users. And this is an example that came to me from a company who makes software for running fruit farms. It tracks the expenses and revenue of each field and lets farmers model their income across seasons and locations and varieties. The idea for this software came from a farmer who needed it to improve their own farm, and then they found it so useful that they spun this off to a company that produces this. And the goal of a berry farm in the Australian market is to plant the right varieties at the right times to guarantee steady supply across a harvesting season as long as possible, and to keep their labour costs throughout that season steady and under control. It would be great, of course, if a farmer could have access to information from beyond their own fences to know what their neighbours are growing and what experiences they've had. Perhaps there's a neighbour growing some wonder variety or has hit on some winning planting schedule. But yeah, right, farmers know their data has value and they're sick of being screwed over by big data. So they've developed a natural tendency to be reluctant to let the data out of their hands. It's not even really a competitive thing. The best outcome for the berry industry is that supply is nice and even and there's no gluts. There's no price crashes. So how can we create a win-win situation here? As I said, for the past few months, we've been working with an Aussie startup that has a platform for this, and their ecosystem is an open platform for data sharing and cognition. It allows data producers to balance their right to privacy with the opportunity to monetize their data. It's also a way for data consumers to negotiate access to the data that they want. And finally, it's a platform for analysts and coders to monetize the use of the algorithms and models that they develop. So we start by defining a schema. This simply defines the format and the semantics of the data we collect. We use the JSON schema project format largely because it's not XML. And for each schema you're going to use, you create a silo. And this really is the same concept as a hat. It's a place that you control where you put your data for a particular schema. And SAM operates a big Elasticsearch cluster for hosted silos, or you can host your own silo. You bring data into your silo either via API or via message bus. We like to use MQTT because we use it for pretty much everything. It's kind of the garden hose of IoT. Now, somebody wants to do a computation. Perhaps the Strawberry Growers Alliance is going to produce a variety performance report. So they choose the schema representing agricultural yield, and they define a query which says, say, give me all the strawberry farms in Southeast Queensland. The central system runs that query, consults a bunch of silos and says, yep, I've got 150,000 records from 600 silos. Now the buyer specifies a computation. They supply an algorithm and a schema that describes the output. This is like a tool or a model in the HAT ecosystem. The schema says this script is going to output a percentile table. The combination of that query, the proposed algorithm, and the price on offer become like a buy offer on the stock market. The sell prices from the data owners are either going to result in a transaction or they won't. And you can leave your offer out there in the hope that people might lower their price, or you can revise your offer. But when a transaction happens, we generate what we call a data carnet. In the dirt ages, a carnet was a legal document which gave you permission to import a particular product. In the digital age, this is essentially a digital certificate that contains that query, the code for the algorithm, and the addresses of the silos. It embodies the agreement to share data for a particular purpose for a particular period of time. And to do that computation, I present my carnet to a computation enclave, which is just an Apache Spark cluster hosted on AWS or somewhere, either existing or newly spun up for the purpose, but controlled by somebody that all the parties trust. The enclave uses that carnet to obtain access to the silos and pulls in all the data it needs. And I've glossed over some details. It's possible this transaction might be more in the nature of a futures contract, where data that doesn't yet exist is going to come eventually via an Apache Kafka stream or something. But however we get the data, the computation runs, the output is checked against the schema, and yes, I know it's impossible to be 100% sure that there isn't a side channel, but we do a best effort to make sure that the information that comes out the end conforms to what people agreed was going to be delivered. And at the end of the day, the data owners get paid, the buyer gets their answer, the enclave gets erased, and everybody's happy. Provided, of course, that the enclave operator isn't evil. Now we get to the freaky part. Is there a way to do something like that without having a trusted third party, without even copying any data? Well, this is an active area of research, and there are some techniques that have gone from theoretical to practical in just the last few years. The first of these is called private set intersection. It's the equivalent of doing a database join where you have one table and I have another table, and neither of us learn anything about the rows that don't form part of the join. There's a C++ library from Google called Private Join and Compute that implements this. If I have a table of names and values and you have the same, we can compute the intersecting rows and the sums of the values without revealing any of the other underlying data. Now, this isn't perfect. It is possible for a malicious participant to learn some things about the other party's data by supplying essentially unknown plaintext attack from their side, but two relatively honest parties can cooperate. So how could we use this? This is another real-world example that I heard about from someone who implemented it. You're a motor insurance company. You've got lots of insured vehicles and a number of claims. I'm another motor insurance company, and I've got some claims too. We'd both like to know if Betsy is ripping us off by insuring her car twice and claiming twice. But it's against the law for us to reveal claims data. So how can we determine if there's any duplicate claims? Well, this is one of the simpler problems that a private set intersection can solve. We choose an identifier, probably the VIN number or the rego number, and our associated value can just be the number 1. We run the private set intersection algorithm, and out the end comes any vehicles that have duplicate claims, and the total is the number of claims for that vehicle. You're busted. Now, if you think that's cool, you will love this. What if we could do more things to data without seeing the underlying values? What if we could do mathematical operations on it? Homomorphic encryption schemes let you encrypt some data, give it to another party who performs operations on the ciphertext, and when I get the ciphertext back, I can decrypt it and I get the answer that I would have got if I'd performed the operation on the original text. People have been theorizing that this is possible for 40 years or more, And there's quite a bit of overlap in both researches and techniques with public key crypto, but it's only just recently that we've actually had some progress, and this is now possible. You can think of these homomorphic algorithms as an evolution of public key crypto that includes error correction. A value is going to encrypt into a much larger ciphertext value that has some allowance for noise. I can throw numbers in there, and as long as I don't throw too many in, it won't overflow, and I can somehow get the answer back out. It's complicated. I've read the papers, and to be honest, my eyes glazed over after they started running out of Greek letters. But the good news is that you don't really need to know how it works. All you need to know is that it isn't unlimited magic. You can do certain operations, you can do additions and multiplications. If you do too many, you'll exhaust the noise budget and the magic smoke will escape. But it does work. You can't branch or compare, so figuring out how to do some useful work within these constraints is tricky, and it is an active area of research. So far, we've got protocols to compute means and standard deviations. Microsoft have released a library called SEAL, which stands for Simple Encrypted Arithmetic Library, which is written in C++. There is no free lunch, so these algorithms tend to be slow and produce large outputs, but there are cases where they can do useful things. So I want to give you an example from health. Let's say there's a deadly condition known as strawberryitis. A number of local hospitals have seen patients with this disease. We want to know the total incidence of this condition and the distribution of recovery periods. But the health insurance information protection law says that the data may not leave the hospital even if it's encrypted. So let's say I take two numbers, which both happen to be 0 initially, and encrypt them to produce 2 buckets of gibberish. I send those buckets to the first hospital and they add their patient data. They send it to the next hospital who adds their patient data. The second hospital passes it to the third hospital, and so on. And it's important that it doesn't come back to me in between, because if I give you a bucket and you put your data in and you give it back to me, I can compare the two and work out what you put in there. But if it goes all the way around and comes back to me, then I can decrypt the accumulators and work out the average data and the statistical distribution that I'm interested in without ever seeing the individual data, and no party can learn what any other party contributed to that computation. And I think that's pretty freaky. We are nearly done, but we are not completely done. There is one more thing I want to tell you about. Not only can you do simple calculations on encrypted data, you can also run neural net processing on encrypted data. Again, from Microsoft, we have a reference implementation of a library which lets you encrypt your data and then send it out for cloud processing by a neural net, which only ever sees the encrypted version. So what could you do with that? Well, after we've chipped away in this talk at all the reasons Facebook might want to be able to see what you had for breakfast this morning or what your child sang at the school play last night, one of the last justifications they have is, but our magic algorithm helps us show you the things you care about most. Well, firstly, they can stick their curated timeline where the sun don't shine, but secondly, I have some hope that if crypto nets get powerful enough, they can solve this too. If you're using TensorFlow, then Microsoft's SEAL folks are working on incorporating homomorphic encryption into that so that you can train your model on encrypted data and operate on encrypted data also, which means you never, ever need to see the plain text data. I hope you can appreciate that that is really quite revolutionary. And then finally, we have the possibility to encrypt the model itself. TensorFlow models are designed to be serializable as Google protobufs so that an app can pull a model down from a server. And there's a link down there about how to do that. But work is also happening on incorporating homomorphic encryption into model handling so that the model can be kept secret for commercial reasons. I don't have time to go into the details, which is totally a lie because I don't understand them yet, but this is an area that I will also be watching with great interest. So we have come to the end, and what I hope I've demonstrated in the spirit of this week is that there's actually quite a lot of scope for improvements in the way that we handle private data. There may be little hope of getting some of the big incumbents to change their ways, but there is hope for a new breed of privacy-preserving enterprises. We've looked at ways that data owners can retain control of their data. We've talked about keeping tighter control of who has access to data. Proctored computation allows parties who might not trust each other to utilise a trusted third party. And finally, the emerging fields of homomorphic encryption allow for multi-party computation to occur without requiring any trusted party. So, thank you very much for your attention, and I hope that I've helped you to think about privacy in a different way. These slides will be available on my website. I would be delighted to take your questions now, but I believe I have 10 seconds left. So thank you again for your attention.
Thank you, Christopher, for another excellent presentation. We have a small token of our appreciation from all of us here at linux.conf.au.
Thank you very much.